All right, so in this video we want to talk about a basic concept dealing with two-dimensional vectors. Namely, we want to look at the magnitude of a two-dimensional vector. Okay? And first of all, what is magnitude? It's just a fancy word for the length. So magnitude is just the length of a vector. All right? So nothing complex. So if we want to find the magnitude of a vector, we have a certain notation for that. So let's consider the vector v. We'll call it v. And let's say that vector is written in component form as 2, -7. Okay? Then if we want to describe the magnitude of this vector, then the magnitude of v is written as v within vertical bars. Okay? So it looks like absolute value. Absolute value is what the vertical bars represent when you put a number inside. So if you put a vector inside, it means magnitude. All right? You could write it like that, or if the vector does not have a name, a label, such as v, you could just write the vector in component form within the vertical bars. In either case, that means magnitude. All right? So let's actually see if we can determine the magnitude of this vector v. All right? So let's see if we can figure that out. So consider this vector and determine vertical bars v, the magnitude of v. So the best thing you can do, maybe, especially at first, is draw a picture of the vector and just see if you can figure out a way using mathematics to determine how long it is. So vector 2, -7, you pick some initial point for the vector to start at. It's got a horizontal component of +2. That means it's going to move to the right 2 units. And a vertical component of -7. That means it's going to go down 7 units. So I need to pick some initial point on the board here that's going to give me enough room to move right 2 and down 7. So I'll pick my initial point to be maybe like right here. And that gives me room to move right and down. So I'll move right 2 units, and then I'll move down 7 units. So here's my initial point, here's my terminal point, and the vector in all of this is the vector that starts here and terminates down here. So this purple guy is vector v. And we would need to know how long this vector is. What's its magnitude? And the good news is for us is that vectors, when they're given using the horizontal and vertical components, horizontal is always perpendicular to vertical. In other words, the angle here between the 2 and the -7, that's always a 90-degree angle, which means this is a simple right triangle. So if you want to know how long this vector is, or the magnitude of this vector, you simply apply the Pythagorean theorem. So in other words, the magnitude of vector v, or you could say the magnitude of 2, -7, both of those are correct, is simply going to be the square root of this leg squared, so 2 squared, plus this leg squared. And notice when you consider it just as a right triangle, the leg length is actually 7, not -7. However, if you happen to use -7 and put it here, you'll still get the same thing as if you square +7. So it's not really a big deal. But we usually don't put the 7 or the negatives when we're measuring lengths of triangle sides. And so simplifying this, you get 4 plus 49, that's 53. So the magnitude of this vector is the square root of 53. So that's our exact magnitude, right? We haven't rounded anything there. So sometimes we'd like to have a better understanding of what that number is. So I'll get out my calculator and type the square root of 53. And as a decimal, that's approximately equal to, let's say 7.3, all right? So this is an approximate magnitude. And so in application type problems, this may be a better sort of answer than this. But if someone just gives you the approximate answer to a problem, there's no way that you can go backwards and get the exact, right? But if someone gave you the square root of 53 as the answer, you could always use that to approximate it yourself. So they each have their pros and cons. Either way is fine. Lots of times you'll give the exact answer unless you're told to do otherwise, okay? So that's the magnitude of some two-dimensional vector, pretty simple. Let's do one more example that we don't want to overcomplicate. By the way, you might notice something. There is a pattern here. If these are horizontal and vertical, then those are always the numbers you square here in your Pythagorean theorem. All right, so you can sort of take that shortcut, but I recommend really understanding why this process works first. All right. Now let's try a different vector that's even simpler. But sometimes we overcomplicate the simple problems. You can probably relate to that. So let's say we want to determine the magnitude of the vector 0, -8. And so when you draw this vector 0, -8, there is no horizontal component. You're not moving left or right. You're just moving down. So we'll choose our initial point up here to give us room to go down. And then our terminal point is down here 8 units away. And the vector is the vector that starts here and terminates at the bottom. So I need to draw my arrow in. And now I can see the vector, okay? So the question is, what is the magnitude of this vector? Well, since there is no horizontal component, there's no right triangle. You literally just look at the vector and ask yourself, how long is it? Well, it is 8 units long. And that's it. The magnitude of this vector is 8. It's 8 units long. And notice the answer is not -8. Magnitudes will never give you negative answers because it's the length of a vector. And so in that respect, these vertical bars behave somewhat like absolute value, right? If you don't know, absolute value measures a distance, and a distance typically is not considered to be negative. All right? So that's magnitude of a two-dimensional vector.